First example is write an algorithm for addition of two numbers. Okay, so you have to accept two numbers from user, add those two numbers and print the result. Getting very simple elementary example. I'm just starting with very first example. Okay, so now we'll write the sequence of steps using simple English, and that is what algorithm. Algorithm says, like, if you want to solve any problem, then write the detailed finite sequence of steps, and if you follow it, you'll get the desired result. Now in this case we have to add two numbers. Just give a logical start to tell that here the algorithm is starting. Getting? Then we will accept two numbers. Accept two numbers, suppose A and B. Okay, the two numbers are accepted. Now third, we'll add these two numbers, okay, and store it in one more variable called C. So I'll write C equal to A plus B. Now we can write in this way also. Some books mention like this, like add A to B and store in C. This way elaborated. Why? Because anyway it's not a program, isn't it? Is it an actual program? No. It is just a sequence of steps written in simple English. Getting? And these all steps you have to ultimately convert into program. So when you convert into program, you'll use that respective programming language rules. So you can write in this way also, or as I said, in simple expression form, like A equal to B plus C equal to A plus B. Now next is you have to print this result, right? To print C, whatever we have got, and then indicate that here the algorithm is over. So I'll write stop. Okay, that simple it is. I hope it is clear to you. Okay, now few examples I'm going to give to you people also, some as homework also, some we are going to solve. This was just a sequence. Now we'll take some in which decision also is to be taken. Some examples will take where we have to do repetition also. Repetition means same activity you have to repeat again. Some examples in which we will take decision. If this is true, we'll do something. Otherwise, we'll do something else. So that type of examples also I'll take. Okay? So this first example is clear to you. Okay, we have to write an algorithm for addition of two numbers. This is some logical indication. Okay, from here, the algorithm is starting. Then I have accepted two numbers and I have stored in A and B. So you are going to accept it from keyboard. Getting external input, that is from keyboard, will accept it and store in two variables. One is A and another is B. Then we are going to add these two and store in one more variable C. And then whatever result we get, that will display it, okay, on the monitor. So standard input is from the keyboard and standard output is monitor. So on the monitor will display the result and then will indicate that here the algorithm is over. Okay, right? So just give me quick confirmation if this example is clear to you. Okay. Yes, no doubt. Prishita is asking, can we write add B to A? Yes, doesn't make difference, because in mathematics addition is which operation? Commutative. I hope you know this terminologies, no? Commutative. Commutative means the order change, the result is not going to change. A plus B and B plus A is same, isn't it? Multiplication is also commutative. A into B and B into A is same. But division, subtraction, they are not commutative. A minus B and B minus A is not same. A divided by B and B divided by A is not same, isn't it? So accordingly, it won't be wrong. And as it that is what as it is written in simple English, the same thing different people can express it in different way. Okay. Okay. So all are saying yes. This example is clear to you guys. One more example I'll give you. Let's see. Some time I'll give to you people also. Write an algorithm for finding area of triangle. Okay. Now generalize. It's not a right angle triangle. Okay. Right angle triangle means base and height we give. So if base is given and height, so directly you write like half base into height. This is just a generalized triangle. Getting? So write an algorithm for finding area of any triangle. In short, for you people, I'll write any triangle. Means a triangle which is having 3 sides. Okay. Is it possible? Now this is a triangle which is having 3 sides, A, B and C. Rishabh is asking like, do we have to input? Yes, we have to input 3 sides. I said no, it's a generalized triangle. We won't accept base and height. Base and height not accepted. From the user, these 3 sides we are going to accept. Side A, side B and side C. Okay. And from that we have to calculate area. Is it possible? Do you recall? In such case, there is one formula.
I don't follow.
Exactly. Very good. You remember it. A, that is area, is equal to S into S minus A into S minus B into S minus C. Getting Heron's formula, he said S minus C, sorry. Okay. So S into S minus A into S minus B into S minus C is under root, and S is A plus B plus C divided by 2. It's 2. So you have to add all 3 and divide by 2, and whatever S you get, that you have to substitute here. Getting? So S, then that average whatever, that is S minus A, S minus B, S minus, and then display it. Okay? So the formula you got to know. Now using this formula you can calculate, I hope. Right, no? See. Here can I write logical start, then read 3 sides of triangle A, B and C. Okay, the 3 sides we have calculated. Then we are going to calculate S, right? You can say like calculate or compute S, that is S is equal to A plus B plus C divided by 2. Getting? Then I can write like this, compute area. Okay, that is area is equal to square root of S into S minus A into S minus B into S minus C. Is it? Fifth, print area and then 6th step stop. Okay, so this way the logical sequence, and then later following these steps will convert it into a program. The program, which language you are going to use, as I said. So the same sequence you can see and convert into Python also. Same sequence you can study and convert into C program also, depending on which language you choose. Okay. Okay, so this example I hope is clear, right? Trigonometry and all, so you can, there can be different ways, right? As she said, we can put a perpendicular and then, but as the question only is saying that except three sides, side A, side B, side C, right? Side A, side B, and sides. So directly we had one easy formula. That's what yesterday the theoretical thing we studied, steps of problem solving, right? Many just study it as a theoretical term, but that thing you have to apply here practically. That 4 steps I told, understand the problem. Okay, so we understood the problem is finding area. Then second was to get an overview solution, and in that find out all the possibilities. So see, like some told use heroine's formula. Now you are saying use trigonometry. Someone else can say ki there can be a one more solution. So find out if there are possible solutions, and then you can decide which one is the better one or optimum, the best one, and then you can pick that, and then you can write sequence of steps for it, and last you will convert that steps into actual program, right? So hope this example all of you have understood. Next example I'll give you, like find out whether the number is positive or negative. Okay, meaning we have to accept a number and check whether the number is positive or negative. So write an algorithm to accept, or write an algorithm to find whether given number is positive or negative. Okay, now till here all the examples which we are taking, these examples, they are just sequential. In the sequence they are getting performed, first, second, third, fourth, in series, in sequence they are getting executed. But many times in our real life problems also, everything doesn't happen smoothly, from first till last, isn't it? You have to do some operations based on conditions also. In real life also, many times we alter our flow, right, according to the conditions. Like see, today only, just now also, we had already first decided 7:30 to 9, smoothly it will go. No, if no problem come, every day smoothly 7:30 to 9 our class will go. But now the problems have occurred. Problem is like some have college, some don't have. So now we have to take some decision. So if it is, so we'll take this time. Otherwise, I'll take some other time. So see, these such situations which occur in real life, they are going to appear in our programming problem solving also, right? So these examples are not sequential. First two examples were going serially one after another. Here we have to take decision, and based on the decision then we have to decide whether it is positive or negative. So how do we decide it is positive or negative? By comparing it with 0, isn't it? Basic mathematics from school days we are learning. If the number is less than 0, it is negative. Greater than 0, it is positive. Or otherwise it is 0, right? So first what I'll do, I'll give the logical start to tell that here the algorithm is starting. Getting? Then I'll accept two numbers, A and B. Okay, now these two numbers we have accepted, done. Okay, now we'll check whether A is, sorry, we don't have to accept two numbers, only one number, no? Right, no? That is mistake I did. Accept one number n, suppose. Okay, now I'm going to check whether n is greater than 0. So if n is greater than 0, then okay, we are going to display that the given number is positive, right? So print positive. Okay, or in more detail, that given number is positive. Okay, then we'll check whether n is less than 0. Okay, you can write it by else also. You can do the comparison that way. I'm writing given number is negative, and if n is equal to 0, then print given number is 0, and otherwise stop. Okay, so just a flow I gave. Now here can you see what output is going to come depends on the conditions. Okay, so it's not a sequential code, means first to last all steps are going to get executed. In this case, some may not, depending on the condition. Like if your given number is 35, so this will get run, but this too won't do any printing. As your number is 35, so 35 is greater than 0, it will print. But as it's not less than 0 and not equal to 0, this too won't get printed. If it is minus 50, so this won't get printed. This second is true, so this is printed. The third won't get printed. So in this case, selective it is happening.
So we don't have to
Getting?
compute anything like 0 minus
Nothing, no,
number.
like directly you can compare it. No, in this example there is no computation needed. We are just comparing with 0 the given number. Whatever the number is, that number I am just comparing it with 0. So if the comparison is satisfied, that is true, so we are printing it is positive. If this comparison is satisfied, then we are printing this. And if this comparison is coming true, then this thing. Getting, no? Clear? So we are just comparing our given number with 0. So what is kept a reference as 0. So if your number is greater than 0, it is positive. It is less than 0, it is negative. And if it is exactly 0, then it is 0 only. Right? Okay. So hope you got it. This question also. Right? Now suppose I give you people 2 minutes. Okay. Write an algorithm to find maximum of given 3 numbers. So I'm going to give 3 numbers and I want to just find out maximum of that 3 numbers. Okay, can you solve it? Take some time, take 2 minutes, okay, and try to find solution for it. You have to accept 3 numbers and then check who is maximum. So you're just going to compare one with the other 2, isn't it? What do you say? You'll compare one number with the other 2. So if that number is greater than the other 2, then that is maximum. So if the first number, clear? You can, to store the result. No, you want to store the result. Yes, you can. He's saying that can we introduce a 4th variable in the algorithm? Yes, in which you'll store maximum and then finally you want to just display that maximum. Once only you'll do the printing, isn't it? Yes, 100% valid. Right? Maximum questions you can solve. Now, here I'll take from my side few questions, but for practice if you want, I'll give you many more questions. Now, a logical start I'll give. See, read three numbers A, B and C. Okay, now we will check whether A is greater than B and A is greater than C. Then, as Rishabh said, can we store it? So we will store it. Max equal to A, I'll write. Okay? Then, if B is greater than A and B is greater than C, means I'm checking B greater than other two, then max is B. Okay, you can write else also, if else, that way also. I'll take an example, that type of example. C greater than A and C greater than B, then max is C. And then as he said, like if we can store, take fourth variable. So I also have taken the same way. So I'm checking whether A is greater than the other two. So if A is greater than other two, A is maximum. But suppose A is not greater than other two, then check whether B is greater than other two. Yes, so B is maximum. Or check whether C is greater. Okay? And then finally we are going to display max. Isn't it? Print max. Whatever has come in max. And then stop. Example, suppose we will try to check its effectiveness. Yesterday I told you, what do you mean by effectiveness? That is, if you take some sample data and try to apply the steps on that sample data, so using paper pencil we should be able to evaluate this whole steps on that sample data. So I'm going to take some sample data and I'll try to apply these all steps on that sample data. And using paper pencil, if I'm able to evaluate these statements on that sample data, we'll say the instructions are effective. Okay? So suppose A given is 7, B given is 3 and C given is 8, suppose. Okay? So first it will check whether 7 is greater than 3 and 7 is greater than 8. Right? 7 greater than 3 and 7 greater than 8. So no, 7 is not greater than 8. 7 is greater than 3 but not greater than 8. And you have written and, means both should be true. So this comes out to be false. So it will check the next one. Now it will check whether 3 is greater than 7, 3 greater than 8. No. So it will check whether 8 is greater than 7 and 8 is greater than 3. Yes. 8 is greater than 7 also and 3 also, both. So in max, what is stored? C. That is 8. And then it will come here, print max. So what is there in max? 8. And then stop. Getting? No? So this way you can evaluate it. One more example I'll give you. Now this one sure I'm expecting from you guys. You write an algorithm to find solution of quadratic equation. Okay? Bracket, consider all cases. Okay? All cases means what? So all the possibilities, whatever the situations come in finding out roots of quadratic equation. So find an algorithm, write an algorithm to find solution of quadratic equation, right? And we have to consider all cases. Okay. Now I hope you know quadratic equation. Means, is it a polynomial of order 2? As it is order 2, therefore it is called quadratic. If it is order 3, we'll call it as cubic equation, right? So it is order 2. So every quadratic equation is of the form ax square, right, plus bx plus c, right, equal to 0. Right? This is the quadratic, and this a, b and c are coefficients which you have to accept from user. So from user you'll accept a, b and c, and for that a, b, c we have to find out the value of x, and possible value of x are 2. Why? Because this is quadratic equation. So possible 2 values of x you'll get. Getting? Now actually what is the formula for calculating x? It is minus b, right, plus or minus, that's the reason, once plus once minus, therefore 2 solutions, right, under root of b square minus 4ac upon 2a. This is actually formula, but this value, that is b square minus 4ac, what you get, based on that the solutions are depending. So this b square minus 4ac can be positive, can be negative, or 0 also. So based on that we have to take the decision, and that's what I said, consider all cases. Consider all cases. So if it is 0, you'll get one solution. If it is not 0 but it is positive, so you'll get another solution. And if it is negative, so you'll get complex conjugates. I hope you know complex numbers. So you'll get 2 complex conjugates, right? Complex conjugates we write like this, na? A plus bj, j also you write, or I, it depends what you want, and another will be a minus bj. That a is called as a real part and b is called as an imaginary part, isn't it? Somewhere in 12th complex numbers you have done, is it?
Yes.
Now we'll take d, okay, and that d is b square minus 4ac. Okay, this b square minus 4ac I'll call d, and now on d's value we are going to take decision. So one condition is 1, that is d is 0. If this d comes out to be as 0, okay, so both the roots will be same, means both solutions x1 and x2. Is it? I hope you are understanding. Both are going to be minus b upon 2a, because that part comes 0, isn't it? So it is minus b upon 2a. So both the solutions will be this thing. Now second, if d is, second situation, if d is positive, that is greater than 0. Okay, now all this writing I am doing it by mouse, so you have to understand it. Now it's not a
We just print the real roots, right?
clear. So no, but when d is positive, then you have to take the root of it, d's root. So 2 solutions you'll get.
No, I meant, do we also print the complex one?
Yes, all conditions you have to. I told you, you have to write an algorithm in which all cases you have to consider, right? So, all possible cases are to be considered. So when d is positive, what will be your solution? Minus b plus that root of d upon 2a. Okay, understand now this handwriting, because I'm not writing it by marker on board. Minus b minus root of d upon 2a. Okay, so 2 solutions we got. Now the third situation is when d is negative, right? Now when d is negative, first calculate 2 parts. One is the real part and the imaginary part. Okay? Now real part will be this thing, minus b upon 2a. Okay? And imaginary part will be, okay, root of, already it is negative, so we are going to take negatives, negative, because finding root of a negative is not allowed, isn't it? And your value d is already negative, isn't it? As it is less than 0 means it is already negative. Suppose it is minus 5. So minus 5's minus will become positive 5, and then you can find root of positive 5. Correct? In some books they write mod d, mod d. Mod d means take absolute of it upon 2a. Okay? Now you got real and imaginary. Now your solutions. What will be your first solution? That is x1 r plus this imaginary part j. Okay? And what will be second solution? Same, r minus I j. Clear? And then this x1 and x2 you have to print. In all situation, after this also print x1, x2, after this also print x1, x2, or after this also print x1 and x2. Okay? So hope you understood this case. Can we write algorithm for this? First of all, are these all three cases understood? Then we can proceed with the algorithm. Okay, which part I have to repeat? What we'll do is, I'll tell you all the situations. First is ax square plus bx plus c.
Sir, I wanted you to repeat what you asked. I understood the algorithm.
Okay, so that's what I'm asking. Are all the three cases clear to you? Right? So if all the three cases are clear, then you write an algorithm for this. Okay? See, we will write. First, I'll put a logical start here. Okay, all of you. Then, accept or read three coefficients. Okay, coefficients A, B and C. That is the main thing. So that three coefficients are to be accepted. Done. Then we'll compute D. Okay, and what is D? D is equal to B square minus 4AC. Okay, so D is computed. D means that expression which is inside that square root. Okay, so directly we are not calculating square root, we are just taking that b square minus 4ac first. And now based on that we have to take decision. See, if d equal to 0, then what will be your x1 and what will be your x2? Both will be same, that is minus b upon 2a. Okay? Now, if d is greater than 0, then x1 is minus b plus square root of d upon 2a. I hope you're understanding. Okay? Any point, doubt, please ask me. And second will be minus b minus square root of d upon 2a. And if d is negative, then we'll first calculate the real part. Real, if you want to write like this, real equal to. The real part is minus b upon 2a. And what is imaginary part? IMAG if I write like this. The imaginary part is square root of minus d upon 2a. Do you agree? Now why I am doing square root of minus d? Because d is already negative. So negatives negative will become positive and then we'll take the square root of positive. Now what will be your x1? Is real plus imaginary j. Okay, and what is your x2? Real minus imaginary j. Okay, and now the seventh step is print x1 and x2. Okay, and eighth step is stop. I hope it is clear to you. Now when you'll convert this into program, depending on the language, getting, so you will have to use the appropriate facilities which those languages have given. Getting, like if you go for Python, so there directly we have complex numbers as a data type. So in Python, complex numbers data type we have. So we can directly convert it to complex number. But like C has not given. So in C we just have to do printing in this way. Real plus imaginary, real minus imaginary. So through printing we will do all this work. Right? So it depends on the conversion. Okay? So good. All are saying yes. So you got this example. Now moving to some more examples. Some examples of repetitions also will take. Now in this case it was all decision making, right? These few examples which we took in this, some decision making was happening. Now one more example I'll give. Very simple example we'll take. Like write an algorithm to print first n natural numbers. Okay, n you are going to accept from the user. So like suppose n is 7. So you have to print first n natural number. So 1, 2, 3, 4, 5, 6, 7. These numbers we have to print. Okay. Now depend on n what you have given. So n is not fixed. Is it right? N is a variable value. N is not a constant value. N value will be depending on the user. What user has given input. So if user has given input 10, so first 10 natural number. If user has given input 5, so first 5 natural number. Okay? So in this case, we have to do repetition. Like in this previous example, just check. In these example, it was everything sequentially, everything fixed order. There was no change in the path. Path was not changing. The path was fixed from first step till last. Here also from first till last. But here the flow was changing based on n. So if n is positive, this part, so this 2 won't run. If this is true, the first and third won't run. If this is true, the first 2 won't run. So same case in this or in this quadratic also. If your d is 0, so this is run, then this 2 won't run. If d is greater than 0, the first and third part won't run. So it was controlled on the basis of condition. Now sometimes you need to do the same activity again also, right? In the same case in real life also, like you have to attend college till syllabus doesn't get over, right? Now if you are very sincere student, so you will attend till the end, till the syllabus doesn't get over. Some students till the attendance is not 75%. Once the attendance is 75%, they stop going to college. So it depends. So you're going from home, college, attend, come back. From home, college, attend, come back. This you are repeating it for some time. In programming also, sometimes you have to repeat some logic again. Getting? So here also you have to do that. Okay. So what I'll do is I'll keep one counter n you'll accept from user. right? And then we'll keep one counter which will start from 1. Counter means which is keeping track. Okay, counter is a variable which keeps track of how many times the activity is done. You understanding? Means I told you that you do every Monday fasting and do it for 16 times. Okay, I know you don't do any fasting and all, but I'm saying ki do fasting for Monday and do it for 16 times. So obviously you'll keep a count, no? One count. Somewhere on the calendar you'll mark, or somewhere in your phone, in notes section you'll put, or somewhere reminder ki how many day, or in your mind you'll keep it. Getting? So Monday equal to 1, then one Monday over. Then next Monday you'll increase that 2, one more Monday 3, and this way you'll do it for 16 times. And if your counter has become 17, means you have already completed with 16 times, so you stop doing fasting. Same mechanism here. So this I is a variable which will keep count of how many times the printing is done. Okay? So first time I is 1. Okay? So is it greater than n? I initially is 1. So is it greater than n? No. So print this I, and then increase it by 1 and make it 2. Again check, is 2 greater than 7? No. So print it and make it 3. This way it will go on. Some stage will arise where 7. Is 7 greater than 7? No. Print it and make it 8. But when you'll check 8, is 8 greater than 7? Yes, so you'll stop doing printing work. The work of printing you will halt. Is it clear? So I hope you're understanding what is to be done. So quickly I'll tell you the steps, and on similar basis I'll give you some examples. So first activity is, I didn't give the logical start. Second, read n. N means how many natural numbers you want to print. So how many natural numbers? First n natural number. So that n I have to accept from user. Next, see, I can write like this: initialize, okay, I by 1. Or this is more elaborated in English. So as I said, algorithms are written using simple English. So how you will express that thing can vary from one person to another. Some person may just write I equal to 1, that's all. So some may write in a very detailed way like this: initialize I by 1, or initialize I to 1. Or someone may just write I equal to 1, that's all. Isn't it? So start, accept n, initialize your I by 1. Okay? Now check whether I is greater than n. So if I is greater than n, then we will write go to some step. Now that step number we don't know. Okay? But if I is not greater than n, so can we print I? Okay? Then can we add 1 to I? That is I equal to I plus 1. This is again elaborated. Some may not write this. Some may just write I equal to I plus 1. I equal to I plus 1. Means you're adding 1 to I and storing the result in I. So if your I is 3, so 3 plus 1, 4, store it. 4 plus 1, 5, store it. 5 plus 1, 6, store it. This will go on. Okay? So if your I is not greater than n, if your I is greater than n, it will go to that step. But if it is not, so will it print I? Means will it display I? Yes. Then will it increment I? Yes. And then after that, again come for checking. So I'll write go to 4. Getting? So go to 4 means I'm telling that ki come back to 4th step. So go to 4 means it will come here and again check whether I is greater than n. Yes, then go to the step number 8. But if I is not greater than 8, sorry, n, it will print it, it will increase it and come back. Okay, now 8th step is stop, right? So here also can I write go to 8. Okay, so I hope you're understanding. Like suppose manually we'll try to run. See, start, read n, suppose n given is 5. Third step, initialize I by 1, so I becomes 1. Okay, then it is checking whether your I is greater than n. So is 1 greater than 5? Is 1 greater than 5? No. No, so it will print I. So will it display 1? Then will it add 1 to I? Means this I becomes 2. And after that it will come again back to 4, where it is checking I greater than n. Is 2 greater than 5? No. So print I, increase I by 1, come back to 4. Again there it is checking is 3 greater than 5? No. So it is printing 3, incrementing it by 1, making it 4, and then coming back to 4th step. Is 4 greater than 5? No. Print it, make it 5. Okay, print it, then make it 5, and then come back here. Is 5 greater than 5? No. Print it, increment it, and again come to 4. But is 6 now greater than 5? Yes. Therefore go to 8, and 8 is stop. Okay, so I hope you're understanding what I'm trying to say. Right? Yes or no, all of you? So we are printing that first n natural numbers. Okay, now more examples I'll give, but meantime what we'll do is we'll quickly read. Shall we quickly read advantages and disadvantages? Okay, coming to advantages part. ठीक है, तो few advantages according to हेलो हेलो दरवाजे बंद कर. हेलो. Okay, so quickly we'll just go through the advantages. Okay, and then we'll try to solve some more, or I'll give you some homework, and then we have to go to the second technique, that is flow charts. So about flow charts also we have to discuss, and then finally we'll be discussing about pseudocodes. Okay, so advantages, what you can say about algorithm. So in algorithms we use simple English, and we write our algorithms in a detailed step-by-step manner, isn't it? In a very basic way, at a very basic level, in step-by-step in English we try to express our algorithm. So obviously it is going to be easy to understand. Getting? And when we write algorithm, we try to see that each and every step are definite. Definite means clear and unambiguous. So obviously when you'll write algorithm, all the steps will be clear, all the steps will be unambiguous. Getting? And when you're writing algorithm, your programming language is not into your mind. Ultimately, in which programming language you're going to implement. Getting? So when you're writing algorithm, you're just keeping in focus English, and Using English, you are trying to write the steps. So ultimately, which programming language, whether Java or C or Python or Pascal or Fortran, we are not knowing at that moment. Therefore, any person who will read this algorithm will be able to understand it. Getting? So it is not depending on, as it's not depending on any programming language, any common man can understand it. Means any technical person, if reads your algorithm, by reading the steps, that person can know that for what the algorithm is or the purpose of the algorithm. Getting? And as they are written in simple English, it is easy to debug also. Debug means you understanding, that is tracing how the functioning of each and every step is going on. Like sometimes if it is going wrong or it's not giving you the desired result, so you can trace it, each and every steps you can again trace and see where the problem is. So tracing these English statement is quite easy. Getting? And as we have also followed effectiveness. See, when I'm using that 5 factors, yesterday 5 properties I told. So while writing algorithm, we also follow effectiveness. Effectiveness means all the instructions are written in such basic level that we are able to do it by paper pencil also. So as we have written each and every step at so basic level, that converting these algorithms into program is going to be a easier task. Means it can be easy to convert an algorithm to program. Okay, then some disadvantages are also there. We'll discuss about that. Before that, we'll just quickly go through disadvantages. So as I said, that it is a step-by-step representation for the solution of your problem, so which makes it easy to understand. Okay, then all the steps are definite. They are following definiteness property, meaning each and every step is clear and unambiguous. So an algorithm uses a definite procedure, that is each instruction is clear and unambiguous. Yesterday I gave an example. Never will write in an algorithm a step like this ki add 5 to x or y, you decide. Such statement we won't write. Okay? Then while writing algorithm, which programming language ultimately you're going to use to convert into program is not in focus. Use simple English and just write steps. So it is not depending on any programming language. And as it is not depending on any programming language, any common person when reads your sequence of steps, they will be able to understand it. Getting? So it is easy to understand for anyone which is not having any programming knowledge. Okay, then debugging. Okay, so every step in an algorithm is having its own flow, its own sequence. So therefore, if you trace that sequence, you'll be able to find out where the mistake is. Correct? So it is easy to debug. And already I said that these all algorithms, when we write, we also try to follow effectiveness property. Yesterday I told you what is effectiveness. So as we are following effectiveness property, getting? So they are already in a so simpler way, it is easy to convert it into program. So by using algorithm, the problem is broken into smaller step, hence easy for the programmer to convert into program. Okay. Now some drawbacks are there. Drawbacks like it's a time consuming work. As you're writing these all steps in English, you can say it's a time consuming activity, but still it is a part of documentation. You will understand it when in third year you learn software engineering. Third year MT, there will be one paper called software engineering. So in that software engineering, you will realize the importance of this all flow charts and algorithm. They are all part of documentation.
Hello,
Correct?
sir.
Huh? Huh?
Sir, your voice is breaking.
It will be problem
Your
from your
voice is
side.
breaking.
I guess problem is from your side, not from my, because my side internet is, it's a broadband. So
Okay, I'll check.
I guess from your side it may be an issue, means a network issue from your side, right? Others like Prishita, Astik, you're able to hear me?
Now I can hear.
That's what I said. Because from my side, I have kept the internet proper with high speed internet, so it never gets disconnected on all. Because I have to, because whole day I have to take lectures, so never issue will be from my side. Network issue from your side, you can check. Okay, so coming to, so are the advantages clear to you? Main things you can remember, like as they are written at a very simpler level, easy to understand. We follow definiteness, therefore it will be clear, ambiguous. While writing algorithm, which language we are not keeping into focus. Therefore, any person who doesn't know any programming, then also he can read the steps and can understand it. Okay, and they are having its own sequence. So therefore, if you trace it, you'll be able to find out where the problem is, logical error. And when we write algorithm, we take care that each and every step is effective. Okay, means they are written in so basic level that we can do it by paper pencil, and therefore to convert it into program will be also an easier task, right? And then the limitations, as I said, time consuming work. Then using this simple English, showing branches and loops is little difficult. Branches means you got, no, like decisions. Okay, if this true, then do this work. Then if this is false, then you'll check another condition. If that is true, then do some other work. Otherwise, some else, which we just now did it for quadratic equation or finding max of 3, right? So putting decision. Then the last example, printing first n natural number. I used loops. So that was also complicated. I checked the condition. If true, then go there. No to do this and come back again. So performing loops and branches is not that easy. Ease is not there, which you will get it in the third technique, that is pseudocode. We are going to learn the third technique also. Okay, and many times your colleges prefer the third one only. Means many times your college say that, okay, instead of writing in simple English, you write pseudocode. Pseudocodes also they give correct. Okay, so in pseudocodes we'll see that okay, writing loops and all become more easy. Okay, and if your problem is too complicated, okay, problem is a very big problem, so that problem writing in this simple English form becomes difficult. Many times that problem you have to divide into many sub problems, and for every sub problem separate algorithms you have to write. Getting example, if I say like I want to do addition of two matrices, so to accept one matrix is also one big algorithm. Adding two matrix is a separate algorithm. Printing that matrices is a separate, because printing is not just one step of matrix, because matrix contains rows and columns. So there are many elements, not single element. So printing a matrix is also going to be a separate algorithm. Getting? So as I said, like a bigger task, writing bigger task becomes difficult. And only writing algorithm is not sufficient. Ultimately, you have to convert it into program. So there's no excuse. You once you write an algorithm, finally you have to convert it into a program. Getting? So writing algorithm, as I said, time consuming work, difficult, or you can say not that easy to show branch and loops. Okay, big task. If you want to solve very complicated task using algorithm, directly you cannot do. You have to divide it into many sub algorithms or sub problems, and for each sub problem you have to write a separate algorithm. Getting? And already I said algorithm is not a program. It is just a sequence of English steps which is just telling you how to solve the problem. But ultimately you have to convert this algorithm into program. So this step you cannot run away. So it is necessary to convert program into convert it into a program by using some programming language. So you have to study that programming language. You have to select a language of your choice, study it, and then all these algorithms which you have written, you have to convert it into program using that language. Okay, so that is the main problem. Okay, so till here I hope you understood the concept. Okay, so one more example we'll take, and then in the next session we'll start with flowchart. What do you say? So flowcharts, then the symbols I'll give of flowchart, again their merits, demerits we'll discuss, and some examples of flowcharts we'll solve, or the examples which we solved today, that only will convert it into flowcharts also. Okay. So one more example I want to give you, that is advantages, disadvantages. I hope clear to you guys. So write an algorithm to find factorial of given number, okay, and that number is greater than 0 or greater than equal to 0. So write an algorithm to find factorial of given number. Okay, and what is factorial? I hope you know it. Factorial is multiplication from 1 till that number. Getting? So if you are told to find out n factorial, so it is multiplication from 1 till n. Getting? So 1 into 2 into 3 into 4 till n. Like if it is 5 factorial, so 5 factorial is 1 into 2 into 3 into 4 into 5. Getting? So now this factorial you have to compute. Okay. Now in this case, n is variable. Is n fixed? No, it is variable. And as it is variable, you cannot do this whole multiplication in one attempt. Because how many multiplications are to be done, that depends on n. If n is 5, we have to do 5 times. If n is 6, 6 times. So as n is only not fixed, so these number of multiplications are not fixed. So you have to go for repetitions. Getting? You have to go for repetitions. Okay. Now here what we'll do? N, so obviously we are going to accept from user, right? Then what we will do is we will take one variable I, which will keep count of whether this multiplication is done n times or not. Getting? Whether that multiplication is done n times or not. And every time what we'll do, we'll multiply, getting, this I with the previous answer. Okay, like see, 2 into 1 is 2. Then that 2 into 3 is 6. Then 6 into 4 is 24. So every time you're getting some answer, and that answer you're multiplying with next number. Again you're getting some answer, multiplying with next number. So temporarily we have to store the answer till now what we have got. Till now how much answer we have got. Because with that answer we are going to multiply next number. With that answer we are going to multiply next number. So that I'll take as f, which will be initially 1. Getting? So initially f will be 1, I will be 1. Okay, and every time what I'll do is I'll multiply this f with I, and store the result in f, and then increment I by 1. Hear carefully what I'm saying. Every time I'll multiply f with I, and whatever multiplication answer keep again in f only, and increment I. Get it? Clear? So hope the process you're understanding. And this will go on till your I doesn't become greater than n. If your I has become greater than n, stop. But if I is not greater than n, then what you'll do, you'll multiply I with f. Okay? See this one. I with f. You have to multiply I with f, and whatever answer you get, store again in f. Okay? Whatever answer you get, again store in f, and then increment I by 1. Okay? And last, whatever remains in f, that is your answer. Okay? See, the procedure I'll tell you. N is accepted. This is your I and this is f. And I told you initially I is 1, f is 1. Okay? Now tell me, is 1 greater than 5? Is 1 greater than 5? No. No. So multiply this 2 and store it in f only. So tell me, what is 1 into 1? 1. Store in f and increment I by 1. It becomes 2. Okay? Now again check. Is 2 greater than 5? No. Okay? So it is not. So again multiply this 2 and store in f. So 2 into 1 is 2 into 1 is 2, store in f and increment I by 1, 3. Again, is 3 greater than 5? No. So again multiply this 3 into 2, 6 and make this as 4. Okay? Is 4 greater than 5? 4 greater than 5? No. So again multiply that 2 and store in f and increment I by 1. Okay? Again, is 5 greater than n? No. So again multiply this 2 and increment I by 1. Now I is how much? 6, which is greater than n. Stop. And when you stop, print this f. What is f? 120. That is factorial of 5. Okay? Somewhat idea you might have got it. I'm sure. Isn't it? Clear? So if you have got that idea ki what is to be done, so every time what you'll do, and in f what you are going to store, the multiplication till that instance. Okay? Till that moment, how much multiplication answer we have got? Like 1 into 2, that answer. 2 into 3, 6. 6 into 4, 24. 24 into 5, 120. So till that instance, whatever answer we have got, that will keep in f. Okay? And I will keep the count that have we done that many multiplications or not. Okay? So hope it is clear to you. Sure. Quickly I'll write and give you the algorithm for it. See, first what I'll accept, n, read n. Second, I'll initialize, okay, I and f by 1. That is I equal to 1, f equal to 1. Third step, we will check whether I is greater than n. If I greater than n, then go to some step. Okay? That will fill later. But if I is not greater than n, so I told you compute what? Compute f is equal to f into I. Okay? Means instead of writing this, only this expression if you write is also okay. F is equal to f into I. So I is multiplied with f and the result is again stored in f only. Then next add 1 to I. That is again I equal to I plus 1. You don't want to write in detail, you can just write this equation. That's all. You don't want to write this all extra English things. So you can write just f equal to f into I equal to I plus 1. And after that, we will come back to step number 3. Is it right? We are multiplying I with f, storing it, incrementing I by 1, and again coming back to 3 to check whether I is greater than n. If not, again do the same work. Multiply I with f, increment, come back. But at one stage, when I becomes greater than n, it will come to step number 7. Okay, where we will print f, that is the factorial, and 8, that is stop. I hope you are agreeing with me what I am saying. Right? Yes or no? If doubt, ask me. Is it? If you want to note down and keep it, it's good. Should have solutions. What you start from 0, I or F? I. Ah, very good. Rishabh already told. Because you are multiplying that F with I. You know, no? Right? So when you're multiplying f with I, and if I is 0, so till final your answer will be 0, because you know anything multiplied by 0 is 0. Okay? Got it? No? Yes, he's saying yes means he got it. So here, as I am every time multiplying I with f, f is equal to f into I, f is equal to f. So if you start I with 0, so 0 multiplied by f is 0. So though later I becomes 1, then also no meaning, because f is 0 only. Okay? Got it. Some may do it in the negative or reverse order. They will start I from n and they'll keep decreasing. Okay? So see all the steps which we have discussed yesterday. 4 steps I told. In point 2 I told, find out all possible solutions, and then take the decision which one is better for you. So some may try from I as n, and for every step they'll keep decreasing it by 1, and when I becomes 0 they will stop. What I am doing, when I becomes greater than n, I am stopping. So in that case they may start from the other way, like this. Okay. I they start from, okay, suppose 5, and f is equal to 1 only. Okay, so 5 to 1 is 5, and next time I will become 4. Getting? I will become 4. Then this will become 20, and I will become 3. Then this will become 60, and I will become 2. Then this will become 120, and I will become 1. Again, this will become 120, and I will become 0. And the moment I become 0, you have to stop. So reverse way also someone may do. So there I equal to I plus 1, instead of that I equal to I minus 1. Here, instead of checking I greater than n, you will check whether I is less than 1. So if I is less than 1, means it has become 0, it will stop. Okay? So different ways are there of writing the same problem. Okay? Hope you understood. But for multiplication you'll need it, no? Or you can do it this way, n only you'll decrease it. Okay, he's saying we won't need a counter. So what you can do, you can multiply n only with f and decrease your n. Right, what you're saying. Okay, he's saying f is equal to f into n, and every time I'll decrease n by 1, and I'll keep count on n only. Means I'll check whether n has become 0. But only the problem is your n will get loss in that case. N will disappear.